Okay, folks, we're back. Moving on to section 14.2 now, and I think it's letter B in your notes, and there's really nothing else in the notes other than just a big blank there. And there's a graphic from your book that shows you the pH scale and the pH of some common items. I think you may already know this, that if it's so 7 is neutral. I'm going to show you where that comes from. And then below 7 is acidic, above 7 is basic. And what we're trying to do is the math associated with all of that. And it's just going to take some time. I'm not going to work all the problems that are in the notes. I'm going to work a few of these, and then you can finish them for homework. Again, the section in your book is quite good. So just to introduce the concept of pH, I don't think your book does this. I don't think I'm copying that. Excuse me. If we have 100% pure water at 25 degrees Celsius, this is something we've already done. Water in action and reacts with itself. Everything here is aqueous. Oh, I need to make a small addition. I was just checking over your homework from section 1. There's a synonym. In the homework, I believe I used the term amphiprotic. It's the same thing as amphoteric. Those are synonyms. So these mean that a proton can either be accepted or donated. So if this is an example, autoionization of water, you should be able to figure out which water is the acid, which one's the base, based on the Bronsted definitions, and go from there. I'm not going to do all that now. This is a bit of a silly example to do this. If we set up an ice table, well, we would ignore water because it's a solvent and it's there in such abundance that we don't worry about it. And it's also heterogeneous. It's a liquid where the other two are aqueous. Perhaps for the sake of argument, I could put those here. So if we did an ice table, those would be 0 plus x, x, and x. Well, what am I doing? Well, you already know that the equilibrium constant for this reaction is called the Kw, the autoionization constant for water. And I'm going to make this a shorthand. Remember, H plus is a shorthand for H3O plus. Let's keep it simple. Fine. So if we wanted to set math up here, that would be x squared, just x times x. Well, we actually know the value for this. I gave you that before. That's a constant for water at 25 degrees Celsius. It's a good number to know. One thing I don't think I did was the units. The units here would have to be molarity squared. 5. And that's a pretty easy one to solve. You take the square root. Maybe we're starting to see some familiar numbers here. 14, 7. What does this mean? So, in neutral solutions, the acidic component equals the basic component. That kind of makes sense. It's neutral. They are equal. Under those conditions, the molarity of each of those is 1.0 times 10 to the minus 7th mole. Not a very big molarity. So that's one kind of relationship to keep in mind. All right, so the math. I'm going to show you the math, and then we can take it from here. I'm going to keep writing so you don't have to watch me erase a bunch of stuff. We're going to introduce logarithms. So on your calculator, if you find the logarithm button, I think I brought my calculator. Oh, give me a second. So find your calculators and find the logarithm button on there. And we don't want natural logarithm. We want log base 10. So log, not ln. And let's get into some of the math here. And this is going to take some time for you to sort through. So if you're taking notes here, just keep going down. Logarithms are very useful in science because they take numbers that are very abstract, like 1 times 10 to the minus 7th, and turn them into something a little bit more useful, like 7. A little bit easier to get your head around. That's what logarithms do. They kind of compress the data into something a little bit more easily understood. So, and we put this, for mathematical purposes, this little p in front. pH is the most common one, but that's not the only one. When you have the p function, what that means is you're taking the negative, because that takes a number and watch, it takes a really small number, a negative, makes it positive. It's just there for that reason. The negative logarithm of whatever variable it is you're doing. I'm just using a y as a placeholder here. It doesn't have any physical significance or chemical significance. It's not like we're introducing a new term. So whenever you see p and then some variable, it's the negative logarithm of that variable. So there's 3 of these we're going to use. pH means the negative logarithm of the H plus concentration. pOH means the negative logarithm of the OH minus concentration. pK, K is the equilibrium constant, is the negative logarithm of the equilibrium constant. That's what it means. So that's the first piece of this puzzle that you want, is that that's what this means. I'm going to show you these now, the inverse equations of these. Maybe it's a little bit early. Again, I'm kind of winging this a little bit here. Actually, I'm not. These become more calculator exercises. So if you're given the H plus, the OH minus with equilibrium constant, or you calculate it somehow, how do you get the appropriate p-value? Just take the negative logarithm of those things, and that's, how about the reverse? What if you're given the pH, given the pOH, given the pK? How do you solve for these variables? Well, this is algebra you may not have seen for a while. If you want to calculate the H plus, well, you have to bring the negative over here and then do the inverse logarithm. So on your calculator, inverse logarithm, well, that's the same thing as 10 to that power. So 10 caret negative pH, or just inverse log, however you want to do it. So, one direction to calculate pH, pOH, pK, to calculate H plus, OH minus, and K. I think I have all those right. So those are useful relationships to know. I'm going to try to put up some kind of a diagram so you can keep track of all these calculations. But that's how it works. Based on some math, sorry, my computer was about to shut down. Based on some math we've already done, that's pretty straightforward. Okay. So let's see. I'm going to keep all those equations here. The whiteboard's going to look really messy when we're done, but hopefully your notes are nice and organized. So that's one set of relationships. Memorize them, but if you see the patterns, you shouldn't have to memorize all these equations. The next set of relationships we're going to want is how do these two relate to one another? If we have more H plus than OH minus, that's an acidic solution. If we have more OH minus than H plus, we have a basic solution. So how can we actually use some math to relate these two terms together? It's actually pretty straightforward, and we start with something we already know. Because this is the equation that relates it to. And again, remember, So we're going to do some math here. What I'm going to do is take the minus logarithm of each side. So we're going to take the p, which actually means power. It was French, I think. So the French phrase for that is puissance, which is a really cool word. So it just means power, negative logarithm. So I'm going to take the negative logarithm of kW. I can do that as long as I do it to the other side. Equals, now, when I take the logarithm of two terms that are multiplied, I can split them up into two other terms. That's a legit move algebraically. When you take, I think we did this with natural logs before. If I take the natural log of a times b, it's the natural log of a plus the natural log of b. The same applies for base 10 logarithms. But keep in mind, I'm doing a negative log, so I have to keep track of that. Well, see that? That's pretty straightforward, I think. The negative logarithm, well, that by definition, that's not even a substitution. That's just the definition. So the minus log of kW is called pKW. The minus log of H plus is pH. Okay. So we're just taking this here, and we can actually do this a little more simply. Let's see. So, well, I can put a number in here, can't I? Minus log of substitute in a value here. I think I have that right. I'm just actually putting the number in for pKW. And what you're going to end up getting is pH plus POH equals 14. That's a useful equation to know. Yeah, I think that works. Okay, this is sort of one of our linchpin equations, if you will. So if you're looking for things to memorize, you don't really have to. You definitely want to know these, you want to know these. You want to know that pH plus POH equals negative 14, and you also, the corollary to that is H plus times OH minus equals 1.0 times 10 to the negative 14. So that's the relationship without the logarithms built in. So pH plus POH is 14. That's definitely one you want to know. H plus times OH minus is, you definitely want to know that one. And this applies to every solution, not just neutral solutions. And you certainly want to know these relationships and these relationships. It looks like a lot, but I think once you see how they all fit together, then you'll get it. Okay, let's at least do a couple of problems. And I don't have the answers, so let's just try a couple. I'm going to move to the next slide. Yeah, and you just want to look at section 14.2. I think you'll figure these out on your own. The point is this. Where's our end goal here before I erase all of this? What you want to be able to do is if I give you one of these four variables, calculate the other three using all of this math. So if I give you pH, we'll calculate POH. Okay. Calculate H plus. Okay. Calculate OH minus. Okay. So that's what you want to be able to do, is take any one of those and calculate the other three, going through the math. And there's some examples there. Why don't we do A and D. So let's do A and D. If you want to do all the other ones for practice and then check with me to see if you got your answers right, that's fine. 14.2 has a bunch of them. And I'm going to erase all of this, but these, you kind of want to have these handy. I give you, but there's not a ton of these problems in problem set 2 because I don't think you need a lot of them. And the trick is to know what's the most logical first step to take. So we'll do A, and you're given a pH of 3.4. And D, you're given an OH minus of 9.3 times 10 to the minus 8. Is that right? Okay. So again, the key is you want to find all three variables that you don't have. All three variables that you don't have. So if you want to stop the video and just work on that and calculate your POH, your H plus and your OH minus, fine. And here you want to calculate your POH, your pH, and then your H plus, that's fine. What I really encourage you to do though, before you start these problems, as always, does it make sense? This is a pH of 3.4. Let's keep in mind what we're doing here. What should your answers be? A pH of 3.4. That means that this is acidic. Oh, I don't think I really talked about this, the pH scale. So 7 is neutral, 0 to 7 is acidic. That's kind of handy to know. The scale in your notes shows you this. Okay, so you know that this is acidic. What does that mean? That means that your H plus has to be greater than your OH minus. So make sure you check all of that before you do any math. I think it's really good to go through the concepts here before you just start cranking out numbers. So we know it's acidic. That means this, okay, that's fine. So how about this one? This is a little bit more abstract. This is 9.3 times 10 to the minus 8th. Well, what's that? Well, guess what? What's a neutral solution? A neutral solution is 1.0 times 10 to the minus 7th. Okay, this is smaller than that. So in this case, the OH minus that you're given is less than 1.0 times 10 to the minus 7th molar. Well, it's less than neutral. So this is a basic solution, which may look kind of weird. Why would I give you OH minus? Oh, excuse me, that's wrong. That's wrong. Why would I give you OH minus if we're talking about an acidic solution? Because OH minus is always there. It's always there in an aqueous solution. It's just there in a really, really small amount. So because that's less than neutral, the base is less, this must be acidic. But we should just check all of that. So the OH minus is going to be less than the H plus in this particular example. So it's good to go through the concepts before you start doing the math. Okay, well let's do some math. I don't have the answers. I don't know what makes more sense for you. So there's lots of things we can do here. There's pH. Okay, well let's do an easy one first. pH plus POH equals 14. So 14 minus pH, that's pretty easy. 14 minus 3.4. I should be able to do that in my head, but I haven't had all my coffee yet. 14 minus 3.4. Well, duh, okay. So the pOH is 10.6. That's fine. How about the H plus? Well, that's 10 to the minus pH. And the OH minus is 10 to the minus pOH. Now, this is not the only way to do this problem. You may do this problem by calculating the H plus. Maybe we'll do both. So, oh, let me put the number here. Everything should be consistent. Just make sure when you put this on your, don't leave it like this. This doesn't make any sense. Take 10 to the negative 3.4 power on your calculator. Don't leave it like this. I mean, change it into where the exponent is some factor, some integer value of 10. So, this is a strange calculator. So, boom, boom. There's 10 to the negative 3.4. And I came up with, I guess I'll take it to 2 sig figs. So if I round this, this is going to be 4.0 times 10 to the negative 4. Okay, and then the other one. Okay, does that make sense? So the pH is 3.4, which means it's acidic. That means that the H plus concentration must be greater than 1.0 times 10 to the minus 7th, which it is. The pOH is 10.6, which also means it's acidic. pOH is the opposite. And the OH minus concentration is really small. It has to be less than 1.0 times 10 to the minus 7th. All of this should be consistent. You should be able to explain all of this in addition to getting the correct numbers. A little pro tip. I didn't even use that equation. I could have gotten 4.0 times 10 to the minus 4th, plugged it in here, and then calculated my OH minus, and then calculated pOH, but that probably wouldn't be very efficient. One thing I like about this equation, this is a good way to double check your work. Get an H plus, get an OH minus, and multiply the two. Just take this times this. Did you get that? Another pro tip, you won't get exactly that because the error, when you take a logarithm, especially when you take a 10 to the power, the error propagates. It gets much, much larger. But it should be close. So let's just try it. So multiply those two and see if you get something close to that. Oh, okay, well, I got exactly 1 times 10 to the minus 14th, so yeah, okay, that works. So we're pretty confident we did that one correctly. Okay, let's do another one. These you just have to work through. I don't think they're that hard necessarily, but that's up to you. All right, so what are we doing here? So we've already charted this one out. It should be acidic because this is less than 10 to the negative 7th. I'm just going to do pOH first. So pOH equals minus log of that. So the negative, put the negative sign in the log, and then the 9.3 exponential negative 8 parenthesis on mine. And I came up with, okay, it's the PO, it's not that. I came up with 7.03. Let me double check that again. Yeah. So pH is 14 minus that. So this is not very acidic. It's barely acidic. Which kind of maybe sort of makes sense. But that's why these numbers are helpful. Because that looks like a really small number, but it's not that far off from neutral. That's very close to neutral, actually. So this is really, really close. That's actually a good example. I think that's why I picked this one. Very close to neutral, slightly acidic. This would probably be like a really weak acid or something like that. Okay, so we were given this, we have this, we have this. The last thing to do is the H plus, and that's 10 to the minus 6.97. Oh, by the way, actually a better way to do this problem would be to take this value and use this equation. So take this. So I'm going to do it both ways. You should get about the same answer. Or H plus equals 1.0 times 10 to the minus 14th divided by 9.3 times 10 to the minus 8th. And the units here, if you want to follow, those are molarity squared, and that's molarity. And we should get the same answers within reason. So go ahead and crank those out. So, boom, 10 to the minus 6.97. I got 1.07. Well, I guess I can carry. No, I really shouldn't be carrying this many sig figs, but that's okay. So this is going to be 1.1 times 10 to the minus 7 molarity, which again makes sense. If this is slightly below neutral, this should be slightly above neutral. Makes sense. Yeah, and rounding. Cool. Okay, so you just have to play with those. Hopefully you don't, maybe that's too many examples. Some people have done this in the past. I don't know if your book has it. If you Google like a mnemonic device, and somebody helps you memorize things. There's different ways to know these equations. I think I've used something like this in the past. You don't have to do this if it makes sense, but this is a good way for you to consolidate all these calculations. I've seen variations of this. I'm just kind of making this up. So there's 4 variables we're calculating here, right? We're calculating H plus, we're calculating OH minus, we're calculating pH, and we're calculating POH. So I just put these as the 4 corners here. So if you want to calculate an H plus and then get the OH minus, you would take, well actually we could probably do this both directions. So if you want to go in between these 2 variables, Just use the kW, that's all you have to do. Just solve the equation. I could write it solving the equation in this direction, solving the equation in this direction. I think you can handle that. If you're given an H plus and you want the pH, well, that's the minus logarithm. If you have the pH and you want to go the other direction, it's just right? If you're given the pH and you want, okay, make sure I get this all right. If you want to go in between these two, I don't know if that's something that helps you. And make sure I have this right. Let's double check it. H plus, the pH is minus log, pH here is that. Go in between these two, just solve those two. You can just solve for whatever you don't have. Give it the OH minus there. Okay, I think that's right. We don't need to do the cross. That wouldn't really make any sense because that would involve like a two-step cut. So just kind of follow whatever path you need. If this helps you, great. If it doesn't, don't worry about it. And at this point, I'm just going to check the homework. Yeah, so the section 14.2 homework. Cool. Yeah. Oh, okay. A couple things about the homework. So the homework, the homework are more wordy problems. So you have to know what hydroxide, OH, hydronium, H plus. Okay, in the first problem, you're told that things are strong acids or strong bases. So what you have to do there is recognize you're given a concentration, but you want to know what to ignore is the spectator ions. Okay, yeah, so in problem number 7, HNO3, I give you a concentration. I just want to make this a little more real world because it isn't just H plus and OH minus. There has to be a counter ion. So if this is a strong acid, you get this. So the concentration there of H plus would be the same as the concentration given, 0.00165. So the nitrate is a spectator ion. In B, the potassium is a spectator ion. So then you have OH minus. In part C, this would be a di-basic compound. So this will actually produce so if you have the molarity of this compound, which you're given, 0.00213, you'll have to double it to get the OH minus concentration because you get 2 OH minuses for every one that dissolves. And then part D, the iodine is H+. Okay, so, and you're given the answers there. And you're not given the pH and the POH. I think you can crank those out. So do those, make sure it makes sense. I don't think there's any other, I guess 7, 8, 9, and 10. I just give you 4 problems, but do the ones out of the book. Just be able to do these kinds of calculations and be able to explain them. That's really great. Okay, so be able to do those basic math, and that is section 14.2.